All right, hello. This is our FTCE Computer Science K12 certification Module 1 video, and we are going to be introducing Java and talking about using objects. So for this first module, it's going to be an introduction to Java. We're going to talk about variables and data types, expressions and assignment statements, as well as creating and using objects in Java, because this is object-oriented programming we're going to be learning. And then we're going to finish off with strings and some mathematical functions. For your resources for this module, if you look at study.com chapters 1 and 2 in the Java Programming Study Guide covers a lot of what we're talking about here, the data types and the variables and operators. And then in the study.com Computer Science Study Guide, chapters 7 and 8 contain the fundamentals of computer programming, the basics of Java. And then CS Awesome units 1.2 to 1.11 is what we're going to work on this first half of Module 1 that we're going to get started with here. So speaking of CS Awesome, you want to go ahead and sign up for CS Awesome. Go to runestone.academy, go down to register and get started. If you scroll down, click on the sign up page, you'll see you can pick out your own username and then your email as well. And then go ahead and be sure to join Gallagher CSA as your course. And then make sure you don't click the make a course. You're actually joining a course, not making one. And by registering for CS Awesome, then you go ahead and get full access to CS Awesome and the exercises that we're doing. And by having your own username, it saves your progress along the way. In addition to CS Awesome, we're going to be developing programs at home using Java 8 and then our integrated development environment called JGrasp. These are both free programs that you can download from eCampus. I have them up there for you under the welcoming documents, under the welcome opening documents. You want to download the Java JDK, which is our Java development kit, and then JGrasp, which is our IDE that we're going to use to develop our programs in. And our IDE, integrated development environment, is basically like a fancy tool that we can use to write our programs in. Just like you would use Word instead of Notepad to write an essay, because Word has different fonts and colors and paragraphs and things like that and margins, whereas opposed Notepad might just be a text editor. So that's what JGrasp does for us. If you want to go ahead and install this, you're going to install the Java 8 JDK first, or actually it's Java 11, not Java 8. This newer version one is Java 11. Install that first and then install JGrasp. And if you have a school-issued device, you're probably going to have to give your school IT person install that for you because you will need administrative password. So once you have that installed, you can go into JGrasp, and this is what our integrated development environment looks like. We have a window where we type our programs in. We have a window at the bottom where we execute our programs. And then you can also see over to the side, we have all of our files listed here as well too that we'll be utilizing. So our first program that we looked at is going to be the Hello Tester program. And there's a lot involved in this program here. When I run this program, it basically is just going to print out a greeting to the console window. So let's go ahead and load this program into JGrasp, and I'll show you how this works. So here's our JGrasp window. You can see this is our program Hello Tester that I have here, and you'll notice a whole bunch of details. We'll talk about what all the individual parts of this mean. But here's my Hello Tester program, and when I execute this program and I run this, you'll see that it does print out Hello World on my display down here, and there is our first Java program. Now, what do all these pieces and parts mean? Well, let's talk about that. So when we talk about the parts of the program and writing a Java program, there's two ideas we want to consider. First off is the syntax, and the syntax is our the grammar rules of the language itself. Syntax is similar to like your I before E except after C, and making sure that you can follow all the different rules that Java has in place so it understands what your program is. Things like adding a semicolon, you'll see, or putting using the curly braces. We'll talk about some of those syntax rules. The semantics is what a program means, what it actually is doing. It may be syntactically correct, but it might not actually do what you want it to do. So the idea of semantics is what it means. Here's some examples here, like you ain't nothing but a hound dog in English, right? You know what that means. You're calling somebody a dog, but it's really not the proper grammar or proper English, but we understand it. Java doesn't understand something unless the syntax is exactly correct. So it seems like the syntax is going to be hard to master, but really semantics, or what a program means, is actually a lot more difficult. I always tell students, I can teach you Spanish, I can teach you how to speak in Spanish, but I can't teach you how to write a best-selling novel in Spanish. That's a little bit harder to do. All right, we're going to talk about this program right here that we started, the hello tester. I want to talk about all the different syntax rules we have. So if you look at this on your slides, let's break down some of the parts of it. We have public class and then a class name. We're always going to have that. We're going to use those curly braces that you saw to denote blocks of code. Public static void main string args, all of our programs begin with that. You'll notice that there was 2 slashes, and then there is what we call a comment. That's actually documentation that the computer doesn't read, but it's for notes for us to tell us what it is we're actually doing with the program. There's a method call, which is a command to one of the library components that Java has, so that we can execute something that's written as part of the Java library that we haven't written. So in this case, our object is system.out. We're telling system.out, which is our controller that allows us to print things to the screen or to a file, and we'll tell it system.out. The method we're using is println, that's println, and then we're given a parameter in the parentheses, and we're telling it to print hello world. And that's really what that program does. So some of the syntax rules that we see in that program already are things like all of our Java programs must start with a class. You'll notice it said public class hello tester. That's one of our syntax rules. Every class and method must have curly braces where we group our code together. You notice there was a couple of groupings of curly braces in there. Lining your braces up makes our program very easy to read. All of our programs are going to begin with public static void main string args. For right now, just know that that tells the computer where to begin our program, where to look for your first lines of code. We'll break down the individual parts of that later, but just know that that's what we're going to have in our program. And Java knows that this is where our program starts. And then what we did, we had a system.out.println, and we told it to print hello world, and that was a Java statement. And at the end of that statement, you'll notice there was a semicolon there. So we said system.out.println hello world, and we ended it with a semicolon. So you can see all of our basic syntax rules that we were following. Here we had our public class hello tester, we had our curly braces that were lining up our groups of code, we had public static void main string args, which means this is where we're starting. Here's a comment. We want to display a greeting in the console window, and then we told the computer, hey, system.out, and the method is println. We're going to print hello world. Notice the parameter hello world is in quotes. We'll talk about that a little bit later as well too. And then we ended with a semicolon. That's our first program here. So we follow the syntax rules, a couple of things. System.out, some of the most frequently used methods that we're going to see some examples of. We're going to have print and println or println. Print means print whatever's in the parentheses and then stay on that same line. Println means to print whatever's in the parentheses and then move down to the next line. All right, so let's talk about how we build and run and execute our program. So there's a couple of steps that take place. Once we've typed our program in, we're going to do something called compiling the file. And so you'll notice here in this little timeline of events, we used our editor, our IDE JGrasp, to modify our source file. And then we're going to compile it. We're going to turn it into machine language. And in order to do that, we press the little plus button up there on the top, and I'll show you that again. And that's going to change it's going to check our code for syntax errors, make sure that everything's correct. And if it is, it'll create what we call a class file. And then it'll take those class files, combine it with the Java library that exists, and then the interpreter will put it all together, and then we're going to press the little red man up there, the little running guy, and that's going to run our program. So just to recap with JGrasp, I'll bring that back up to the screen. And here we have on our screen our program, and I'm going to press the green button, which compiles my program. It tells me if I have any errors, and then I'm going to press the running man, and it automatically executes and prints out hello world. So let's talk about some common errors that you might see in our programs as well. So a couple of things that we might see, some syntax errors. If you misspell out and say system.ouch, the computer doesn't like that. Or if you look at the next line, system.out.print hello world, but then I didn't close the quote and Java doesn't know where I finished there. Those are called syntax errors, and those are detected by the compiler. So if I go back to my compiler, and let's say in this window I type in system.ouch, so O-U-C-H, system.ouch.println, and then I try to compile it, Java's going to tell me, hey, I've got a syntax error. It doesn't know what ouch is. It doesn't know that I just misspelled something. So that's going to be a syntax error. So I can fix that, make sure I put back system.out.println. And now when I compile it, I've got no compile errors, and then I can run my program and it's going to print out hello world for me. So that works. Those are some of our syntax errors. A logic error is something that is syntactically correct, but it didn't say what I wanted it to. Let's say I forgot to put the O in there, and so instead of hello world, I got hell world, and that's a much darker scenario now, and that's not what I wanted. But the computer doesn't know that. Computer might think you just might wanted to say hell world, and so as a result, it printed out what it was asked to print out in that case. So that would be called logic or a semantic error, right? It's a logic error, something wrong with the meaning of our program. Some other common syntax errors you want to be careful of. Case sensitivity, yeah, it matters. So system has to be capitalized, capital S system. We also have to make sure that we put a semicolon at the end of each of our statements. So if you forget to do that, that'll be a syntax error. Also, what's wrong here? Looks like we forgot to put our closed quotes at the end of our parameter hello world. And then also you can't have a space in the class name like hello space tester. So you want to be careful about that when you're developing your programs. So how do we run these develop these from scratch? Well, here's how we compile and run a program. You can go ahead and start JGrasp at any point. From the menu, click on File, New Java, and then type in your sample program, the hello tester, that will print out hello world for us. A couple of things you could do to make it a little bit easier to use your program. You can say run an MS-DOS window, meaning it's going to pop up a window instead of running it down at the bottom. You could also say view line numbers, which will put line numbers on the side of your code, makes it a little bit easier to read. Make sure you save your folder, save your file, so do a file save as, and save it to somewhere, preferably on your OneDrive, so you can find it later on. Save the file name as hello tester. Remember, it's case sensitive. It's the same name as the class, public class hello tester, capital H, capital T, no space. And then go ahead and click build compile, or click the green plus button, and then go ahead and click build run or the running man, and then you executed your first program, assuming you didn't have any errors. All right, let's talk about some more details that we can get into coding rather than just printing out some words on our screen. Let's talk about variables. What's a variable? Well, a variable is going to be a storage location for a type of value. So in this case, here's some examples. Our variable declaration always is going to include a type. So it's going to tell what type of value do I want to have. Here's some examples: ints, doubles, and strings. We'll talk about that. The identifier, what's the name of our variable, the name of our storage location? This is a name that we give it, so hopefully it's meaningful, like num days for the number of days in a year, or sales tax is 6.5, or maybe just a word that I'm saving in memory as well too. And then we give it a value. We say equals and then give it a value. You don't have to do this at the time where you declare it, but it's always good to give it a starting value like 365 or 6.5, and these are memory locations. So in Java, we have three simple data types that we're going to focus on. We're going to focus on integers, which is int, real numbers or decimal numbers, which are called doubles in Java. These are decimal numbers. And then also a Boolean value, which is a true-false value. And that's not the word true or false, but the value of true or false. And that'll come more into play in the next module, but just know that that's also a data type that we have. So integers are numbers that have no decimals. We have our doubles, which have decimals, and then we have our Boolean values, which are true and false. So when we name our variables, we have to come up with what we call an identifier. An identifier is going to be the name of our variable, like you saw num days or word. And there are some rules. You can make them up of letters and digits and the underscore. You cannot start with a number. You can't use other symbols such as a question mark or a percent sign. You can't use a space inside there either, and you can't use our reserved words like public or class, ones that Java recognizes for certain reasons, and they are case sensitive. So whatever you use, you have to make sure that however you name them with capital and lowercase letters, you do that consistently. By convention, we usually start our variables with a lowercase letter, and then we use camel case, like you saw with some of the examples back there, like num days. The D is capitalized, or the T in sales tax is capitalized. And then also by convention, our class names tend to start with an uppercase letter. And you could use all lower cases or all upper cases, but this is just a convention that you'll generally see most of our variables using. All right, in addition to the identifier, we also saw that we have an assignment operator, which is the equal sign. And this is not a statement about equality. This is how we put a value into the variable. So for instance, I could declare a lucky number, an integer lucky number. Notice I used my camel case for the lowercase l and uppercase n, and I assigned it the value of 13. So now my storage location named lucky number has the value of 13. I could also then change it and say lucky number equals 12. Now there's a 12 in that location, and the 13 has gone away. So that's how we use variables, kind of an introduction to variable declaration. Here is an example. Let's take a minute here, and if I gave you this code, there's a whole bunch of lines of code here. We've got some variable declarations, we've got some print and print lines. I want to know what this was print. If you want to go ahead and pause and take a look at this, this is also example1.java, which is found in the module 1. You can download this file and run it yourself. But let's take a moment and see what this would print. Okay, here we go. This will print this. So let's see what happens here. It says it prints out the score is 0. It prints all that on one line. Why? Because score is an integer that's initialized to 0. I did a print, so the score is, and it stayed on that line, and then I printed score on the same line, 0, and then I went to the new line after I printed score. I created a price variable called, or a double variable called price, 23.25, and I said the price is, and on a new line I printed price. So the price is, and then on the new line, 23.25. I changed my price to 11.37, and I printed it out again, systemed out to print line price, it prints out 11.37. I then have a Boolean variable, I call it 1. Maybe it's for a game whether I won or lost. I start off a Boolean variable, I set it equal to false, so when I printed it printed out the word false, and then I set it equal to true, and I printed it again, it printed the word true. So there's some variables, you can see that they do have the values that we gave them, and we can print them to the screen. All right, let's talk about some operators. I have basic operators in Java as well, very similar to what we have in math. I have addition, subtraction, multiplication, and then I have two things, division and modulus. Now addition, subtraction, multiplication works exactly as you think it does, but division and then this thing called modulus is a little bit different here. So let's talk about those. So division is the division operator, and we know how division works, but if one of them is a double or a decimal number, then the result is going to be a decimal number, which is exactly how math works in real life. But in Java, if both of the numbers are integers, then the result is going to be an integer. So for example, 7.0 divided by 4 is 1.75 because there's a double here. 7.0 is a decimal number, and it's going to be 1.75. But if I have an integer divided by an integer, 7 divided by 4, my answer is going to be 1. Because 7 divided by 4, 4 goes into 7 one time, and then I get rid of the decimal. Because if I'm doing two integers division, my result is going to be an integer. And then we also have an operator that produces the remainder. It's the percent symbol, it's the modulo function, or the mod function that we call it. It's just like when you learned division back in 2nd or 3rd grade, you had to put the big R, remainder 2 or remainder 3 before you learned about fractions. It gives us the remainder. So 7 mod 4, what is 7 divided by 4? Well, 7 goes into 4, or 4 goes into 7 one time with a remainder of 3. So 7 mod 4 is going to be 3. 31 mod 10. 10 goes into 31 3 times with a remainder of 1. So 31 mod 10 is going to be 1. All right, let's try another sample problem here. What is this going to print? So you take a second, pause here, and work these out. I'll come back in just a second, and we'll go over the answers. All right, using these operators, what does this print? Let's look at this. and it prints out these values. So to go line by line here, what's 2 plus 3? It's going to print out a 5. What's 2 minus 3? It prints out a negative 1. What is 2 times 3? It prints out 6. What is 2 divided by 3? 3 goes into 2 0 times. It's 0.66, but the decimal gets discarded, so it's going to print 0 right here. What about, I have a first, which is 3.5 times 2. So first is going to be 7.0, right? And then second is going to be 8 minus 6. Second is going to be 2. So what happens when I have second is 2, and then third is going to be second plus 9. So third is going to be 2 plus 9, which is 11, right? So now let's look at first divided by second. We said first was 7.0. 7.0 divided by 2, well, because that's a decimal, I'm going to have what? That's going to be 3.5. 7.5 divided by, or 7.0 divided by 2 is 3.5. One of them is a decimal number. I get a decimal answer. But what about this? Third is an integer and second is an integer. Third is going to be 11 and second is going to be 2, right? Because 8 minus 6 is 2, and then 2 plus 9 is 11. So 11 divided by 2 is going to give me 5. Why is it 5 and not 5.5? Because it's an integer. It's an integer divided by an integer, so I get an integer answer. And then finally, what is first plus second times third? It's going to do the multiplication first. It does do order of operations, and then it adds that to my double, 7.0, and I'm going to get 29. All right, a couple other operators I want to talk about here. So there's some shortcuts that we like to use in Java because we're lazy programmers. I could say nickels equals nickels plus 1. What does that actually do? That's something you don't see in math. You don't see x equals x plus 1 in math. But here in Java, you can say nickels equals nickels plus 1, which means what? Take whatever's in nickels, add 1 to it, and then assign the result back into my nickels variable. So if nickels had 5, I would take that 5 and I would add 1 to it, become 6, and store the result back in my nickels location. So nickels is now 6. So that's one way of adding 1 to a variable. I can also, because adding 1 to a variable is such a common feature that we do in Java, we have a shortcut. We say nickels plus plus. Nickels plus plus means add 1 to my nickels location. Likewise, we also have nickels minus minus, which decrements my variable by 1. It only works with 1 and negative 1. You can't say nickels plus 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 and try to add 2 or 3. We have some other shortcuts for that, but nickels plus plus and nickels minus minus adds and subtracts 1 or 1 from or to our variable that we are using it with. Okay, some other assignment operators. In addition, we know nickels equals nickels plus 1. That's nickels plus plus. We have nickels minus minus. But what if I want to add more than just 1? Well, there's shortcuts for that too. Let's say I want to add an amount to my purchase. I could say purchase equals purchase plus amount. So if purchase was $10, I want to add another 5. 10 plus 5 would now be 15. Purchase is now 15. I've updated my purchase variable. Well, instead of doing that and repeating that purchase here and here, I could just say purchase plus equals amount. Add amount to my purchase, same result. Likewise, if I have a balance, say in a bank account, I want to subtract an amount. I could say balance equals balance minus amount, or I could say balance minus equals amount. I get the same result. I also have times equals and divide equals, same idea, store the result back in the original variable. And one other type I want to talk about, or one other function that we can do with some of our numeric values is something called casting. And casting is when we convert from one type to another. And the reason we need to do this is because we know that integers don't have decimals and doubles have decimals, and sometimes we want to convert from one to another. So obviously I can't do something like this. I can't say double total equals a lot, right? A lot is a word, total is a double, it's a decimal number. That's going to give me an error. Well, what if I wanted to convert from, say, double or a decimal number to an integer? Well, I can do something called casting by putting int in front of it, and that gets rid of my decimal. So let's say I had a total that was $1.59, 1.59, and I wanted to convert that to a number of pennies. Well, pennies is an integer. I can't have half a penny, right? So which one of these works properly? If I want to convert pennies, convert $1.59 or 1.59 into how many pennies that is? Well, this first one's going to work because what this does is it multiplies total by 100, so it's going to be 159.0, and then it's going to cast it as an int and just make it 159. Whereas the second one actually would cast total as an int first. It would change 1.59 to 1, and then 1 times 100 would just be 100, and that's not really representative of the number of pennies that I have. All right, finally, what about this one here? New total. If I didn't have that word double there and I just did 1 divided by 3, 1 divided by 3 is 0, right, with integers, but I want the decimal version, so I put double in front of it. It converts 1 to a double, and then I do 1.0 divided by 3. Oh, I'm going to get 0.33333. That's going to be the value for new total. So another couple of operations that we can do with numbers as well. All right, in addition to our variable types that we have, I also want to talk about constants. And just briefly, constants is also a variable, but it doesn't vary. It's something that doesn't change at all. And the way you would declare a constant is you use the word final. You put the word final in front and you have a variable that doesn't change. So I say final double nickel value, for instance, and I say 0.05. Notice that nickel value is all caps, and I use the underscore between words. That's a convention. I don't have to do that, but a lot of programmers will use all capital letters for constants, so you're kind of aware they really can't change, and I can't change them. Okay, let's talk about CS Awesome now that we've looked at some topics here. In CS Awesome, when you log in, you'll notice that each unit is divided into sections. There's some sample coding process. It's an interactive textbook. There's multiple choice questions. There's Parsons problems where you mix and match code, and there's small programs that it guides you through to program. The summaries we have at the end are very thorough, and there's always multiple choice questions, which are great because they tell you exactly why certain answers are incorrect or correct when you go through them. So it gives you explanations for your multiple choice questions. You are welcome to complete as much or as little as you need to get comfortable. Some people are gonna maybe just do a couple sections. Some people might want to spend a few hours on each section. It's totally up to you to how much you spend. Here's unit 1.1. And we're actually gonna start with unit 1, which is getting started. We're gonna start with 1.2, why Java, and you can see about data types and assignment statements and casting, and then all the way down at the bottom, those multiple choice exercises. Those are really great practice problems. I highly recommend that you try those. So that gives you a little bit of practice with programming before we get started. Then our first assignment that we're doing with this module is called cash register. And if you go to module 1, there's a program called cashregister.java. And you want to copy that program to your OneDrive, and then you want to open it and complete the code as it has it listed in eCampus or in the comments. Then go ahead and run, and hopefully you have some of the results printed as well. And remember, let the program do the math. Don't do all the calculations. Do all the multiplication or adding in the program itself. And then you're going to turn in your file in a screenshot. Let me show you what this should look like. All right, so here's the cash register program, and you'll notice it's called public class cash register, public static void main string args. I have a constant quarter value. We talked about constants. And then it says create 2 variables, one called total and one called item count. I already created total for you. Can you create a variable to represent the item count? Well, total is going to be a purchase price, right? So that makes sense to double. Maybe item count should be an integer, an int, and set that equal to 0. And then it says you're buying a coffee maker for $22.75. Add this to your total and update your item count. So I'm going to go ahead and get you started here a little bit. I'm going to do an int item count equals 0. And what would I do for my first item? Well, I want to add $22.75 to it. So that means my total, and I'm going to say plus equals, remember that shortcut? 22.75, semicolon. I've added 22.75 to my total. What do I want to do with my item count? Oh, I want to add 1 to my item count. How do I do that? Oh, I could say item count plus plus, and now I've added 1 to my item count. And what else are we buying? Well, we want to buy a phone charger for $12. That's cheap. A calculator, and then can we fill in this code? The total is, what would go here? The number of items I purchased is what variable goes here. And then, oh, my payment's $100. How do I calculate my change? And then if I wanted to give your change in all quarters, could we figure out how to do my change in all quarters using the quarter value constant? So finish that code. If you have any questions, please feel free to contact me, and try that code in JGrasp and see if you can compile that without any errors, and then go ahead and submit that file in the assignment on eCampus. This is the end of part 1 of this module. I'm going to talk about part 2 of this module, module 1.2, and then at the end of that, we'll kind of sum up all of the assignments all of the assignments from module 1, and I'll talk about that at the end of the next video.